All right, welcome everybody as we continue on kind of with some of the technical thinking in the technical tools module. And again, just as a reviewer, what we're looking at right now with these sections is really the tools to improve side of it, which is kind of the skills aspect from a technical perspective of how we want to go about accomplishing our lean transformation. So in the back half of this, there's a couple sections that we've been covering, and what we'll be focusing on in this section is pull systems. And so I do encourage everybody, if you haven't kind of been following the recommended course through, if you're going to go through pull systems now, make sure you go back and go through the MiFLOW section under the measurement module, because the symbols and the way these maps are laid out are covered in that section and kind of gives you a better understanding of what you're looking at here. If you are familiar with this, then it shouldn't be any issue, but just a reminder to everybody that is something that's worthwhile to take a look at. So we'll start by taking a look, as we have been doing with traditional systems, and then kind of making a comparison to some of these lean ideas. And so in a traditional system, we've got a couple different issues. And the first one is that these types of systems, these types of production systems, require some type of top-down production instruction. And you can see here where the sales order goes to the production control center, and then production control individually tells each one of those three steps what they should be making and when they should be making it. So it's kind of a top-down, forced production scheduling process. The other thing you can see with the dashed hats is with a push system like this, we have in-process stock, we have inventory buildup in between each process. So each step isn't really connected to the other one. They're just in their own silo building to a pile, and then the next person down the line just pulls from that pile as they need it, right? So we've got inventory, we can have a top-down production instruction, pushed production instruction. And what that leads to, kind of a characteristic out of this, as we saw in the continuous flow section, is this type of production setup really has pretty lengthy lead times because of the way we batch build through this. And so what we want to do to move away from that, to really get into kind of some of the core concepts in terms of visually what you see with lean, is this idea of a pull system. And at its kind of the central principles of a pull system is that we structure our production so that the downstream process, again, an office, it could be the next desk over, it could be someone that needs to get an email or something in software, whatever it may be, that downstream process just withdraws exactly what they need, when they need it, and in the needed quantity from the upstream process. We're not pushing things to people, and the downstream, kind of like going to the grocery store, which is where this kind of came from, gets to go shop for what they need to do the job that they need to do right now, right? We're not forcing them to do things. They get to make decisions based off what their demand is. And it looks kind of something like this. This is just a model representation. So what we've got with this is, for the upstream process, there's a store. The downstream process is kind of allowed to go and shop at that store for whatever they need, whenever they need it, in whatever quantity they need it, in order to meet the demand that they're under at any given moment. And so there's a couple key components to a pull system that's going to be standard. The first one is a store for finished goods, and that's where every process is going to have a store where they keep the completed goods that they produce. The other one is they're going to have a store of sorts for their raw material or their parts material. So it's what they need to produce their finished goods. That has to be there at the front end of the cell. And then the last thing is there has to be some sort of communication to tell everybody what they should be producing and when and how many of what. So those three core components. So the first thing we'll take a look at is the store, and this is just kind of a mock-up pull system production process, just 2 steps to produce and then a shipping step. So with the store, they're circled in purple there, and what the store does is it holds all variety of finished goods. So for the sake of this example, we're just going to assume that in this production there's only 4 different things that they make. Obviously, in the real world, it can be more complicated. There's some things to do that we'll do to address that a little bit later on, but for right now, we'll just keep it simple. So you got 4 different products that you make. So each step has a store that has those 4 different finished goods that are kept there. And then that store is also located at the end of the process, right? So I finish it, I put it in my store. What's nice about it is it becomes a visible pace of sales. So I, as a manager, anyone else as a manager, can walk by that store, and depending on the levels of the product in it, we can get an understanding of how quickly things are being withdrawn, how quickly things are being produced. We can see a header behind condition, and we can see the status of the line right at a glance just from seeing that store. And then when we look at, okay, well, how do we decide how much goes into the store? There's a couple things that we consider. It's not really that complicated, actually. It's based on our production lot sizes. So say for the assembly line process, how many am I producing at a time? Do I produce in batches of 1 or 3 or 5, right? So we got to consider that. Then the frequency of withdrawal. So again, at the assembly line, how often is the shipping department coming and taking one? If it's every 15 seconds, that's going to be a lot different than if it's every hour or every other day. And then the last one is quantity per container. So if it's something big and only one of them will fit on the shelf, that's a little bit different than if I can fit 50 tiny parts into a little box that goes on the shelf. So those are kind of the things that we consider when we're determining how much, what quantity of these different parts should be in the store. Now the second key element is the material stock. We'll go ahead and circle it there in purple in both of those steps. So we can see in one step it's a flow rack, and the other for fabrication is the actual raw material. And so what the material stock is it's kind of like a store in reverse. So instead of having all the types of finished products, the material stock has all the types of raw materials that you need to create those finished products. And again, it's located line side, just like the store. So again, it's a visible pace of sales. You can walk by the material stock to see a header behind, what's going on, overproduction, underproduction, is someone late, all of those things. And just like in determining quantities for the store, we need to determine, so we have an expectation of how much should be in the material stock. And there's a couple things that go into that. Again, instead of production lot sizes this time, it's in our usage lot sizes. So do we use 5 at a time, or 3 at a time, or 10 at a time, or 1 at a time? The frequency of supply instead of frequency of withdrawal. So how often will my material stock be replenished once I use everything in it? And then again, quantity per container. Is it just 1? Is it 50? Because that'll change how we deliver it and store it. And then the last thing, the number 3, is this idea of communication. Because it makes sense. We have to be able to communicate with each other what we're producing, what we need to produce, what we're taking. And the way we do this in a pull system is that the customer information only goes to one location. So the orders don't get sent everywhere to everyone all the time. They just come into shipping. And so what shipping does is starts kind of this idea of chain by chain production. And the purpose for it is we want a kind of a smooth, balanced pace of production, right? We talked about it with takt time, continuous flow. And the way we achieve it is through frequent, regular withdrawals from all of these stores. So what happens with this in a pull system is the customer order comes only to shipping. And the customer says, I would like 1 unit of type A. So then shipping now can go to the store of the assembly line where the completed goods are, and they can take 1 completed unit of A and go back and ship it. Now for the assembly line, he sees that that unit has been taken from his store. That's how he knows what he should build next. No one is coming and telling him what to do. He can see right away, oh, this is what I need to be working on because that's what our customer just took. So then he goes to his material stock, takes what he needs, builds a part A, puts it back. Now, for the material stock, that has to be replenished. So to do that, he can go to the finished goods stores of the fabrication cell and take what he needs. Now, fabrication can look at that store and say, well, now I know what I need to do. So it kind of works in these chains where each process is just chained together and everyone is only working on what was just withdrawn. And when we do that, we're not forcing production instruction. We're always building exactly what our customer wanted in the quantity they wanted it at the time they wanted it. And so, we talked about just in that example saying, well, you could just see that something was gone. In reality, we need a little bit better tool than that. And so what we use is this thing called Kanban, this idea of Kanban. And what it represents is it's an authorization for production and material conveyance. So it is the signal that lets everyone know it's okay for me to make these, and how many and what. By the same token, it's what the material handlers say, well, this is what I need to go get, and this is where I need to take it. It's also a visual check, so we can use it as management, so we can control overproduction with it. If there's only so many Kanban cards out there that say 3 each, well, if we end up with 500 parts, we know that something went wrong. By the same time, we can see a header behind condition. If we know we should have this many parts here, and there aren't that many, we know we're behind somewhere. We can immediately start working on fixing that before we shut the line down. Same thing for process status at a glance. Ahead or behind, what's our status, how are we doing? And then the last part is it's a tool for Kaizen activity. We can do it to try and reduce our Kanban quantities. We can use it to try and improve communication, to tie processes together in different ways, to reduce our material handling time, all sorts of different things. And what comes out of that is that there's two different types of Kanban. There's the parts withdrawal, which is kind of the material handling side, and then there's the production instruction, which is what tells everyone in their work cells what they need to be working on. And so, that's kind of an abstract, definition of Kanban. In practice, it can take any shape. This is one of those, again, where everyone is encouraged to develop something that works and is tailored to your situation. This is just an example template. But the key points out of it is that it contains all the information that a team member needs to be able to complete whatever the process is efficiently. In this case, it has the types of material on it, the programs that needed to be run with the equipment in order to produce that part in that quantity, and then it has some information on where it goes when it's done. The same thing for additional information on supporting visual management. So a manager or supervisor can pick this up. With that routing information, they can say, well, this material should be here. Is it here? Is it not? What's my status? Normal or abnormal? So it becomes a real easy at a glance way to tell what's happening on the shop floor in real time and why things are where they are or where they should be or what our problems are. And so when we tie all that together into a complete pull system, this is what we get for our example. So we have our customer order comes into shipping. Shipping gets a withdrawal Kanban, which gives it authorization to go to the store, the assembly line, and take what the customer ordered to ship it out. When they take that out of the store, they give the assembly line a production Kanban that says, hey, I just took this, I need you to make another one. That's the instruction for the assembly line. They take it, say we need to make that. They go get their material, they make it. When they take their material out, they send another withdrawal Kanban to say, go to the fabrication store and replenish what I just took because I don't want to run out. So they go take it. When they take it from the fabrication store, fabrication gets a production Kanban to say, hey, I just took this out of your store, we need you to make more and replenish it, right? Chain by chain. So everything is driven off what the customer actually just ordered and got shipped to them. That's what drives our production, not some schedule. And so then, kind of we talked about before, well, what do we do if we make more than just 4 different things? Well, we cover that because there's 3 different types of pull systems. There's the A type, a conventional system. That's kind of geared towards the example we talked about. Low variety, high volume, just a couple types of parts. We can do that with full stores. The B type system now gets into sequential stuff, and that would be, say, we don't just make 4 parts. Say we make something with 100 different varieties, right? We don't want to keep inventory of all that because that's not going to work. So we can use a sequential pull system to address that in those situations. And then the last one for the C type, it's a combination of both. So say we have a couple stock parts that we make, but then we also do some of this kind of custom high variety type of stuff too. Well, the 2 systems are compatible and they can be integrated to run together seamlessly. So we'll take a look at them just one at a time. And again, going back, I recommend everyone make sure you've seen the MiFLOW section because it'll really help all of this make sense. And in a conventional pull system, the A type, we have, like we just talked about, all the product variations are kept in stores at each work cell, and then Kanban is used as the production instruction to say, okay, I need to take some of this, and you need to make some of it to replenish what I just took, all the way back to the start. And then formal production instruction is really only given to one location, the shipping department. It doesn't have to go to every cell. Every other process, their Kanban is what tells them what to make. So we don't have to worry about trying to manage this big production scheduling system. Now with the B type, it's a little bit different because there is such a big variety. There is a little bit of production control required with this. And so in the sequential system, production is based really off like a sequenced list of products versus just pulling things in stock inventory out of stores. Same concept though. And so what happens is, instead of the stores holding 5 or 6 different things, they only hold one item at a time, right? One by one production, we still want good continuous flow. And then what happens is the production instruction, the sequence, is just given at the very start. So the way this works, everyone still produces to tack time, everything is still aligned and sequenced properly. When the customer comes to withdraw, the shipping department knows they need to be shipping a product every so often according to tack time. So when it's time to ship a product, they can go to the end of the line and grab the completed unit that's there. It's produced in sequence. They can take it and they can ship it. That unit being taken then triggers the, in this case, what's labeled as the downstream process, to grab whatever the next unit is that's waiting on them to take it, do their work, and put it in their store. And kind of iteratively it goes back. The difference with the B-type system is when it gets to the very head of the line, in the last example, the fabrication department, instead of just going to the material stock and replenishing inventory, standard inventory in their store, they now have a production sequence that they look at and say, okay, well the next one that needs to go down the pipe is a type B unit. And that's what they build and that's what they send. Everybody's still pulling from everybody else, but at the head of the line we're kind of sequencing what we're sending into the line because we have so many varieties we can't keep all of that in inventory. It's a minor difference, but it's still a pretty powerful system, and it works the same way. It manages the same way. You get all the same benefits out of it. And then the last type is the C-type, the combination. The map starts to get a little bit more complicated because really you're running an A-type and a B-type in parallel. So this would be if you have 2 or 3 items that are stock, high volume, and it makes sense to do them in an A-type. And then you also have maybe 1 or 2 things that are low volume but are really custom that you run around in a sequence. And so you can do both at the same time. And you use the different types of Kanban to let the downstream and the upstream process and shipping know what they should be making and when they should be making it. And the first question that pops up when we start looking at C-type systems is, well, how does everybody know what's more important, the A-type thing or the B-type thing? And the answer is really simple. We give priority based on time. It's first come, first serve, FIFO, first in, first out. So if an A-type product was drawn before the B-type, that A-type gets replenished, and then the B-type gets built and worked on. It's pretty simple. We keep it all ordered chronologically, and that's how we make sure that everything stays at an equal, an equal and understandable priority. And so just as a review, just to make this easy, this is an important slide. It just kind of covers the differences between the different pull systems, kind of in a general overview way. So the A-type, that standard one, we want to use that for high volume, low variety. So we're making a lot of parts and only a couple different types. So the benefits we get out of that is it's the smallest lead time because you have an inventory store of completed goods at the end of the line. As soon as you get an order, you can go to it and ship it that day. Right? It doesn't have to go through the system and be made all the way through. We also can keep real small inventories. It's really responsive to changes in demand because we just tweak the size of our store in real time. The other nice thing is you've got some self-managed work processes, right? We don't have to tell everybody what to be doing all the time. It's all driven based off what shipping is shipping. And then the last part is the conveyance processes. We can standardize those because every work cell works the same way. The main drawback to that, we've hit on it, is you've got to keep inventory of all the different types if it's going to work, which is a non-starter in some applications. And in those applications, we move to the B-type, which is low volume, high variety. We also, there's lead time to produce built into that because the unit does have to start and go all the way through the system after the order is placed. The nice thing, though, is you really only need a couple pieces of finished inventory, so you don't have to keep as much inventory with a B system as you do for an A. So you're making a trade-off between lead time and inventory. The other thing what's nice about it is you do have fixed production lead times. It's not as short as an A, but you can still fix it, you can still understand it, so when we're talking to our customers, we know we can produce this in X amount of days. The drawback, again, the lead times are longer. When demand changes with the B-type, it's not quite as responsive because we don't have those levels of inventory that we can play with and adjust. And that's kind of the comparison back to the A-type there. And then the last one for the C-type is, it's nice. You get all the benefits of both, but you do kind of suffer from the drawbacks of both. And then the last one is sometimes managing it can be a little bit tricky, especially for organizations that are just now getting into this, because it does require some real relative competency in being able to understand and manage the information flow running 2 different types of pull systems with 2 different types of Kanban going at once. But it does work, and for organizations where it's necessary, it's a great way to schedule and organize production. So then, just in summary, kind of big picture looking at pull system benefits, what we really get out of it is that kind of the highest level, what everyone needs to take away is that we're only producing what is sold when it's sold. So we can't overproduce. We can't build up all of this inventory. We can't guess wrong what our customer demand will going to be. We're building exactly what the customer wanted. It also gives us visual control over our production system, right? Through Kanban, we can see, with our material, what it is, where it should be, if it's in the right place. We can also see ahead behind status. Well, what do our store levels look like? Are they right? Is there too much? Is there not enough? What's going on here? And then the last thing that's really nice about it is we create this self-regulating schedule. We don't have to tell everybody what's going on. We don't have to change our schedules all the time to try and keep up and change it. The schedule is driven from the bottom up, based purely off customer demand, which is our overall goal. And that's, I think, for organizations that get in and get this implemented, that's one of the nicest benefits to the team members on the line is there's very little confusion as to what we should be working on, when we should be working on it, and why we should be working on it. It's a great way to make sure everyone stays on the same page. But unlike everything we've talked about, there's some challenges to being able to implement it. Again, this goes back to talking in the previous section about continuous flow. There's the reason we do some of these things in a certain order because we've got to build some competency and lay the groundwork to be able to do this. Just like continuous flow, we tried to start right at the beginning and jump right into a pull system because that's what we thought lean was. We're going to really struggle. And chances are we're going to make it a lot harder on ourselves to be successful than it should have been. And so the big challenge really that comes out of this is reducing lot sizes, right? Getting away from that batch production mindset and trying to get to a true one-by-one build, right? That continuous flow thinking that we hit on before. The problem is with traditional thinking, and this is not entirely false, as our lot size goes down, as our batch size goes down, the cost goes up, right? That whole notion of economies of scale. And I mean that's true. And so what we look at is, though, there's a way we can calculate what our optimum lot size is, and it's pretty straightforward. So you got cost, you got lot size. So for inventory, as the amount of inventory goes up, the cost associated with that inventory goes up. The other curve is the changeover cost curve. So as the lot size gets bigger, the changeover cost per piece goes down. That's pretty normal. Everyone generally has a good understanding of that. What that results, though, is when we look at the total cost, which is inventory and changeover together, that gives us this blue curve that has a minimum point, where we have an optimum lot size now in terms of cost and quantity per lot. But what we want to do is we want to actually reduce our lot size. But we don't want to just decide we're going to make fewer parts because that's not sustainable and that's not something that will work. In a lot of cases where that's what people jump to, that's why you struggle, that's why you see some failure. What we want to do to be smart about it is we want to change our changeover cost curve. We want to get better at how we change over, because if we can make changeover less expensive, less time consuming, then without doing anything else, just the act of getting better at our changeover shifts our entire total cost curve, which shifts our optimum lot size point, which is how we reduce our lot size in a smart, sustainable way. That's a key idea. And that's what we see. And you can see right there on the chart, that's how we're able to reduce it. And we reduce the cost. So it's not just that we're reducing our lot size for the sake of reducing our lot size. We've actually found a way now to make fewer parts cheaper than the before. And that's what we're really getting at with this. And again, just to hit on it, kind of the key takeaway here of what makes this work is quick changeover. That's what drives this. That's what allows us to make less parts for less money. Quick changeover. And so kind of how this works, again, just to help everybody visualize it one more time, is so if we have kind of a before condition, and we're going to run, we're going to set up, and we're going to run an A part. Then we're going to set up again, and we're going to run a B part, because we have long setup times, so we have to run big part runs for it to make sense. Well, if we can get better about reducing our changeover time and our changeover cost, and really it's time that is the predominant factor in cost, say we cut it in half, Now we can run A, B, and C, and D parts in smaller lots. We can run more variety, be more flexible, because we reduced our changeover time. What that does, more flexible, reduce our inventory because we don't have to run as big a batches, and it reduces our lead time now too. Because if you looked at it before, if we could only run A and B in one day, that meant C and D were going to have to wait till tomorrow. That added a whole day to the lead time for that product. But now that we can run all four in one day, shorten the lead time up. So there's a lot of benefits to focusing on quick changeover to drive reducing our lot size, to drive getting close to continuous flow, to get close to our ideal thinking of one-by-one production, which lets us take full advantage of a pull system. That's kind of the evolution, and that's why we want to focus on changeover. And just as a rule of thumb, because a lot of people ask about this, well, how quick is quick? Just a rule of thumb, if the total changeover time can be 10% of the production time for whatever that part is, then we know we're in the ballpark and we've got it pretty well situated. It's probably worth moving on to other projects. So just to kind of review with the small lot stuff, the reason we focus on it is because we have to be able to build in small lots if we're going to do a pull system. The other nice thing that comes out of it too is that smaller lots, when we do it through reducing changeover and not by just forcing it, we actually reduce our costs too, which is surprising to a lot of people. And again, kind of the key point out of that is when we can get faster at our changeover, we can reduce inventory, but we also increase our flexibility because we can run different parts, we can run more parts, we could fit rework in there if we needed to. It gives us a lot more power, a lot more options. We operate a lot more efficiently as an organization in terms of production when we're running like this. And so that kind of covers pull system and with the special taking a look at small lots and quick changeover, because that really drives a lot of these other programs and skills. So any questions, just direct them to the website as always, and we'll see everybody for the next sections. Thank you.